Hello everyone and welcome to Mox's webinar, Cellular Technology. Do you know your GSMs from your LTEs? I'm Martin McHugh and I'll be your moderator today. If you have any questions at any time during the webinar, please use the questions pane by simply typing in your question and clicking send. At the end of the presentation, we'll do a Q&A session, take as many questions as we have time for. We will follow up with any unanswered questions after the webinar. Okay, let's get started. We'll have a 30 to 40 minute presentation with 10 to 15 minutes of Q&A. Today's presenter is Ariana Drivdahl. Ariana is the Product Marketing Manager for the Industrial Wireless Group here at Moxa. Ariana possesses a wealth of knowledge when it comes to cellular and wireless technologies and understanding how to specify and deploy them within your network or system. And with that, I'll hand it over to Ariana.
Thanks, Marty, and hello everyone. Thanks again for joining us on today's webinar. Hopefully you'll find this next 45 minutes or so informative and helpful to you. And with that, I'm going to go ahead and get started. So our agenda for today, pardon me, comprises of the following topics. I'm going to give you a quick overview of the history of cellular networks and kind of how they came to be. I'm going to give you a quick introduction to cellular for machine-to-machine or industrial applications. Going to give a brief intro of GSM versus CDMA networks and what kind of applications are relevant for each. Then we're going to move into LTE, which is kind of a hot topic nowadays, and how it ties everything together from GSM and CDMA. Then finally, we'll talk a little bit about how you can get information from your devices to where it needs to be, and then we'll finish off with a small summary or conclusion. So the history of cellular networks. The first true what was called 1G cellular network in the U.S. was developed many, many years ago. It was called AMPS, or Advanced Mobile Phone System, and it was an analog. You guys probably all remember those really old brick phones that were literally the size of your heads. That was the old kind of analog 1G type of technology that we talk about. Thankfully, we have migrated off to newer and faster and, of course, sleeker and smaller technologies, but that's where the whole cellular technology kind of began. 2G really started what we know today as the battle of the technologies. There are two competing standards that were developed that are still in use today and still kind of in competition, if you will, today. And those, of course, are GSM, which was developed by some various European companies, and CDMA, which was developed here in the U.S. by American companies as well. 3G introduced packet switching instead of circuit switching, and we're going to go into that a little bit more in detail kind of later on in this presentation, but in essence, circuit switching is kind of like a dinner reservation. You have one table per reservation, or what we say is one circuit per call. It's basically a dedicated line. Packet switching basically divides the data to be transmitted into packets that are transmitted through the network independently. So in packet switching, instead of being dedicated to basically one communication session at a time as circuit switching is, network links are basically shared by packets from multiple competing communication sessions. Unfortunately, the result of this is a small loss in the quality of service that's basically guaranteed by circuit switching. However, the benefit is that there are a lot more users that can essentially be using that at the same time. Then 4G, which is kind of where we are today, is LTE. It started off as kind of the battle of LTE versus WiMAX, and for many years people thought WiMAX was going to kind of win out in the battle of those two, but as most of you probably are aware, LTE has kind of come out as the predominant 4G cellular technology globally, and WiMAX has been kind of moved into more specific type of applications. So an introduction into machine-to-machine for cellular applications. Just a quick note, when I say machine-to-machine, I talk about true industrial applications, whether it's remote monitoring of water wastewater facilities, whether it's remote PLC or HMI monitoring. Those are the types of devices that we refer to, or types of applications that we refer to when we say machine-to-machine or M2M. I'm not going to be talking about kind of traditional cell applications, whether it's talking on a phone or connecting your laptop. That's a little bit of a different scope and not something that I'm going to be covering in this presentation. So what is data acquisition over cellular? Well, as I just mentioned, it's acquisition that's made possible remotely, whether that's down the street or whether that's halfway around the world. Any device that's essentially put onto the cellular network is accessible from anywhere else in the world. Makes it very, very easy when you have a location that doesn't already have a fixed network line. It is a cellular system that connects to local data acquisition systems. Again, whether that's I/O, whether that's a PLC, whether it's a SCADA system, all sorts of devices and all sorts of applications are connected to that cellular network. The nice thing about data acquisition over cellular is it allows system managers or other users or engineers to work with remote devices just as if they were local. So rather than having to physically go to a site and plug in an Ethernet cable or a serial port, for example, cellular technology or cellular M2M technology allows us to essentially be virtual to those devices. So why would you want to go with cellular machine-to-machine networks? Well, there are many locations where phone or Ethernet lines are just too cumbersome or difficult, or let's face it, too expensive to install. A lot of times pulling cable or trenching cable is very, very costly, and it's a lot easier and a lot less expensive to just plug a cellular modem in and let it connect to a cellular network. Cellular location provides better mobility, location, installation, and encryption. The mobility aspect comes from a wireless connection for mobile devices. The installation comes from no access to the local network. So if, for example, you are a machine builder and your machines go to places around the world and your customers won't allow you to log into their local network in order to diagnose or troubleshoot or upgrade those devices, a cellular can essentially be a backdoor into that network. Location, cellular goes places where a hardwired connection just simply can't go. And finally, encryption. There are VPN or tunneling options that are protected, that protect both, the cellular modem and the data that passes through it. So it's a great method of communication, and even though this all sounds wonderful, there are, of course, a few caveats which I'll go over as well. So the cellular technology evolution, this chart is a little bit kind of complicated, but you can see that 1G, which was the old brick phones that we used to use, they were really for voice only. They weren't up to any kind, there wasn't anything built into the standards or into the protocols that would allow you to do any kind of data transfer. 2G is really where we kind of started the voice and data. Though 2G tended to be very, very slow, it was really the first true standard that was able to pass data because it was a digital versus an analog way of communicating. Now, circuit switching versus packet switching. I kind of mentioned this a little bit earlier, but it's kind of important to know the difference because depending on which one your carrier supports, and this of course varies depending on where you are in the world, the hardware that you have to use that supports these two things is going to be different. An old telephone system, which is also known as PSTN, uses circuit switching to transmit voice data, whereas VoIP, which is what we use predominantly here in the US, uses packet switching to do so. As I mentioned earlier, in circuit switching, the path is basically decided upon before the data transmission starts. So the system basically decides on which route to follow, and this is based on a resource optimizing algorithm. And the transmission then goes basically according to that path. It doesn't change, it doesn't deviate. For the whole length of that communication session between the two communicating bodies, the route is dedicated and exclusive. It's released only when that session terminates, which means that nobody else can use your line, nobody else can use your bandwidth, you have no reliability issues of the network trying to switch your packet around. It's a very, very high quality but yet very expensive way of communicating. Now here in the US, we don't have any more networks that have circuit switching. However, there are circuit switching carriers in many countries, including Latin America and in China, and so it's important to note, what kind of carrier you're going to be using. For packet switching, you basically, if you want to understand packet switching, you have to know what a packet is. So the Internet Protocol, which is known as IP, just like many other protocols, basically breaks data down into chunks and then wraps those chunks into structures called packets. Once they reach their destination, the packets are reassembled to make up the original data again. So as I mentioned, circuit switching is old and expensive, and basically what some old analog carriers will still use, and packet switching, of course, is more modern. If you're going in terms of pure reliability, of course, as I mentioned, circuit switching is a lot more reliable than packet switching. However, packet switching is much quicker, and it allows for a much higher capacity than circuit switching. Now, everybody wants to know, well, how fast can my cellular technology go? And the answer to that depends solely on, what generation of technology you're using and also what your carrier supports. So if you look at the old GSM, which was the true 2G or first really viable data transmission type of a communication standard, you're not really going to get very good data rates, a max on the most of about 14.4 kilobits per second. So it's very, very low. GPRS and EDGE, which were considered 2.5 to 2 3/4 G, they can get up to about 171 or 473 kilobits per second. However, when you're talking about actual throughput with multiple users connecting to a tower, you could pretty much guess that it's going to be about dial-up modem speeds. So I don't know how many of you remember the good old AOL days where we had to dial in with a 56K modem, but that's the kind of speeds that you would expect from a 2.5G cellular system, whether that's GSM based or CDMA based. If you're looking to do more of kind of broadband or Ethernet-based communicating where you're going to have a little bit higher bandwidth needs, then 3G or 4G is what you're going to have to look at. 3G, which starts at WCDMA or HSDPA, depending on what kind of network you use, they have a much higher both uplink and downlink. The standard HSPA Plus, which is considered 3.5G or 3 3/4 G, typically tops out at about 11 megs up and about 42 megs down, which seems pretty darn fast, but most carriers will actually rate limit that. So you're going to typically top out with those technologies at about 4 to 5 megabits per second most. LTE, on the other hand, has the theoretical capacity to go much, much, much higher. And LTE-A, which is the advanced version of LTE, in theory can go up to 1 gigabit per second. But of course, carriers will limit that. But true LTE speeds range anywhere from about 5 to 30 megabits per second, depending on where you are in the world, what carrier you're using, as well as how many users are currently connected to a tower at any given time. So what are each of the cellular generations used for? Well, 2G is, the first digital. So, you're talking serial, old legacy, serial kind of technologies is really where 2G is good for. 3G is used for a little bit more of broadband, so whether it's a PLC that needs to be remotely configured or remotely monitored to wireless I/O, these are all kind of valid types of applications for 3G. 4G is, as I mentioned, more of the true broadband type of speeds, and this is where we get into more video over cellular type applications. And I'll kind of go over a little bit more in detail some applications as we go through the presentation today. So it's time for our first poll question. So I'd like for you guys to let us know, what generation cellular technology have you used? 2G, 3G, 4G, or all these darn G-forces are new to me? And we'll give you guys just a few seconds to answer. Of course, you can have multiple generations as well. Some people will use a combination of both 2G and 3G, or 3G and 4G. But you guys can go ahead and just let us know what maybe the latest is that you've used. So we got some good numbers coming in here. Looks like 3G and 4G are kind of neck and neck about now. Going to give you guys just a couple more seconds, and then we'll close it up here. All right, so it looks like 3G is the most popular by just a little bit. 43% of you are currently using 3G. 35% of you are currently using 4G, and then rounding out to cellular is new to me, and I still use 2G technology, kind of rounding out the top 4 there. So appreciate you guys participating. That's kind of the same type of information that we've seen in the market. So again, appreciate you guys answering. Over. So some of the key vertical markets that are used in cellular machine-to-machine, we have the true what's considered M2M, which is our traditional kind of industrial or pipeline, oil and gas, tower monitoring type applications. Then you have AMR, which of course includes things like meter reading, energy management, distribution, and automation. Remote monitoring of SCADA and control is another really biggie for cellular technology. This includes things such as diagnostics and building control. We have asset management, so fixed asset monitoring, high value goods and inventory location. Point of sale and banking is one that's used fairly often actually in the cellular industry, but is not typically considered kind of an industrial application, but still kind of falls under a vertical market that M2M goes into. This includes things like ATMs, cashless transaction, cashless vending. You know, a lot of you can go into a gas station, for example. If you see a vending machine outside and you see a little antenna sticking out the top of it, chances are there is a cellular modem, and what that cellular modem does is it basically keeps track of the inventory that's in that vending machine. When one gets low or empty, it essentially phones home and says, hey, I need someone to come and refill me. And what that does is it basically saves time and money of someone going down and manually doing a physical inventory count. So not, like I said, not quite traditional, but still falling under this kind of realm of machine-to-machine or industrial. Fleet management is also another biggie. Anywhere from vehicle logistics and tracking to rail and controls is used quite extensively. In particular, when you combine a cellular modem with GPS information, it essentially allows carrier operators to keep track of their fleets and where their goods are at all times. Security, including residential and commercial, is kind of an up-and-coming vertical market for industrial machine-to-machine or industrial cellular. People want to know what's going on with their residences and, with their commercial properties. And as you all know, cellular towers are everywhere, in particular in, highly populated areas. So it's a great way of communicating. And finally, we also see medical as another vertical market where industrial cellular comes into play quite often. This includes things like home health care, patient monitoring, and diagnostics. So as I said earlier, cellular is a really awesome technology and it's really flexible, but there are some challenges that come along with that as well. Unfortunately, coverage is still limited in some rural areas with some providers. So, you always have to make sure, hey, if I want to put a cellular modem in here and I want to put it onto the cellular network, can I get a cellular signal? And the best way to figure that out is to literally take your cell phone and try to make a phone call. If you have enough signal for a phone call, you have enough signal to transfer data. In addition to that, most providers will provide what's known as a private IP address, which means that only devices on a local network can access it. Now, if your device is on a cellular network and it's talking to another device on the cellular network, that's probably not going to be an issue. But the vast majority of people are going to be using this, trying to access a device that's inside the cellular network from outside a cellular network. And that can present challenges because the cellular carriers basically have firewalls in place that will block outside traffic from coming into their networks. So we'll talk about how to get around that in just a little bit. In addition to that, many people still don't understand the technology or who to get service from, or really what hardware to use for it. Finally, different countries operate on different frequencies and different technologies, so it makes it hard when you're trying to, build from a global perspective. So cellular is kind of the only communication standard really that's used predominantly today that essentially makes you pay for the amount of data that you use. And traditional networks like Ethernet or wired or serial, of course, once you install them and they're put into place, there are typically no additional charges that happen on those types of networks. However, cellular is very different, and industrial cellular in particular tends to be different from consumer cellular with your phones in the sense that you don't buy voice time, you only buy data time, and that data time is typically not unlimited the way that you would see with phone. So you'll buy, say, a 10 meg plan or a 100 meg plan or a half gig plan or a 2 gig plan, and if you go over that, then you certainly will be charged by these cellular carriers. So one of the really big challenges of cellular is how do you keep monthly airtime to a minimum, and that essentially makes sure that you have the lowest monthly phone or monthly data bill as possible. In addition to that, you have to be able to know how to push data to a wireless device. As I mentioned before, the carriers tend to give out private IP addresses, but they also tend to give out dynamic IP addresses, which means anytime your device reboots, it will get a different IP address. Makes it a little bit more difficult to be able to, push or pull data down from that device. In addition, activation and provisioning issues, you can't just go to your local AT&T store, for example, and say, hey, I want to have a 2 gig data card, because they're going to look at you and say, how many minutes do you want with that? They're just not physically trained or really knowledgeable in pure data type of communication. So you typically have to go to someone in their industrial department, which is hard to find, or you have to go to an MVNO, which stands for Mobile Virtual Network Operator, and they specialize in industrial applications, and they do only data. But all that can be confusing for first-time users of cellular. Also, problem determination. If you have a wireless device that's not functioning properly and you have an unmanned environment, it's obviously a little bit more difficult to figure out what's going on if you don't have someone down there present. And again, usage and billing, of course, as I mentioned, it is a pay-per-use type technology. So how do you keep your monthly airtime to a minimum? Make sure you avoid getting charged for unauthorized traffic. In many cases, the cellular modems essentially are designed to get connected to the internet. So if you have a device that's, spewing lots of data, or if you have someone who plugs in a device to their laptop, for example, it can be used to access the internet, but all of that data costs money. So make sure that only authorized data is actually accessing the internet. A lot of people don't fully understand message sizing and the frequency of their transmissions. So we're very used to thinking in megabytes or minutes when it comes to phones. Hey, I want to download a movie that's, a gig. Or, hey, I want to make a 10-minute phone call. But machine to machine is a little bit different. You want to try to use the least amount of data that you possibly can. And so, you want to try to think in kilobytes, not in megabytes or minutes. In addition, you want to make sure that you understand the protocol overhead. So for example, TCP and UDP, they actually provide different levels of control and overhead, but they also use different amounts of data. So you really want to make sure that you're understanding the protocol that you're transmitting over the cellular network so that you can have a good handle on how much data you're going to need every month. And finally, you want to understand carrier rounding. So similar to the way that your phone works, so if you talk for 1 minute and 1 second, you'll be rounded up to 2 minutes. Similar to that when you use data. If you use just a little bit over a full kilobyte of data, then of course the carriers will round up to the next highest kilobyte of data. So just kind of something to be aware of. Definitely can make a difference when you're talking about sending messages or sending transmissions on a fairly regular or frequent basis. So what types of devices can I connect? Well, the most common ones that we see are Ethernet devices, but serial devices are still used and connected regularly. So when we talk about serial, we tend to talk about things like legacy PLCs, HMIs, I/O devices, things like that, that people really want to bring up to a modern communication standard, but don't necessarily want to spend the money to fully replace, because of course replacing all that hardware can get fairly costly. Ethernet to cellular can connect virtually any Ethernet device to the cellular network. So, whether that's a SCADA system, whether that's, anything else, it really, you really can connect virtually anything. The possibilities are almost endless. So when we say Ethernet and serial to cellular, what exactly do we mean? Well, when we say serial to cellular, it is essentially serial data that's transferred transparently via the cellular network. So what that means is instead of physically plugging into that DB9 port that you may have on your serial device, the modem will plug into that device instead, and typically what will happen is you will establish a virtual COM port on the PC or the receiving end of that data. So where you would physically create an actual real COM port by plugging into the serial device, we create one virtually, and all that data then goes over the air as opposed to through the physical wire. When we talk about Ethernet to cellular, Ethernet data can basically be transferred transparently via the cellular network. So it's again for the same thing, a remote control of Ethernet devices. We're just doing it over the Ethernet as opposed to over serial. So we've got another poll question for you guys, and kind of curious to know what kinds of devices will you or have you connected to a cellular network? So serial, Ethernet, serial and Ethernet, USB, or other. I'll give you guys just a few seconds to answer that for us. And looks like Serial and Ethernet is winning by a landslide here. So we're going to go ahead and close that up. So as you can see here, 74% of you, which is probably one of the highest percentages I think I've ever seen on one of our poll questions, said, hey, we do both Serial and Ethernet. So that's great. Lets me know that you guys are using kind of a blend of different technologies, and you know, certainly Ethernet is second. And I think probably as we get farther and farther along in you know, the 2000 teens here, we'll probably see that number start to go up a little bit more. So appreciate you guys chiming in on that poll here. All right, so we've gone over kind of some of the basics of how, you know, cellular machine-to-machine works, some of the challenges of it. Now I'd like to give you guys just a quick overview of the different types of cellular networks that you'll be able to see. And I'm going to go ahead and start with GSM. So GSM, which stands for Global System for Mobile Communications, why they didn't call it GSMC, I'm not sure. For whatever reason, when they created the acronym, they dropped the C off the end of it. But GSM is the predominant standard globally. It comprises of around 75% of all wireless users around the world. So you can see that's really the major type of technology that's prevalent throughout the world. As I mentioned earlier, GSM started in Europe. It was developed by European countries, and Europe tends to be a little bit farther along and kind of was the one who originally spearheaded a lot of the cellular communications. So that standard kind of spread globally. In the U.S., both AT&T and T-Mobile use GSM technology. Now, because GSM is a global standard, the GSM devices that are unlocked, which most industrial devices are, should be able to work with pretty much any GSM network globally, provided that the devices support all GSM frequencies, and the vast majority of them will. GSM is really the great technology to use if you have any devices that roam between countries, or to users who build devices that ship to different locations throughout the world. So if, for example, you know, you're doing a fleet monitoring, for example, and you know, it's shipping to Europe, and you know it's going to be crossing multiple borders, GSM is the type of technology that you would want to choose for that type of application, because the GSM modems can switch between those different carriers automatically and very easily. So GSM was really the first kind of communication standard that introduced circuit switch data. So if you remember, we talked about circuit switching, that it was great quality, but it required a dedicated line, and so it was therefore costly and very expensive and very difficult to implement. It wasn't exactly a very attractive way of communicating. So GSM basically migrated to the next generation, which was GPRS, and that's when we started to get into packet switching, which was a lot better. But in addition to circuit switched and packet switched technologies, you also have the ability to send SMS or short message services via GSM. What this means is if you have, for example, a mobile sign on a roadside that needs to be changed, perhaps for an ITS type application, what you can do is you can use the cellular modem to essentially send an SMS to that device, and that allows you to change it on the fly just by sending a message versus having to actually use data or airtime. 3G, of course, includes HSPA, which is a combination of HSDPA, which stands for high-speed download packet access, as well as HSUPA, which is high-speed upload packet access for true broadband type speeds. So GSM kind of runs the gamut from very slow to very fast. The one thing that I will say about GSM is 2G is being phased out very rapidly here in the States. So to those of you who are using AT&T or who are looking to use AT&T, they have actually stopped doing activations for new 2G cell modems. So if you're going to be using a 2G network, you definitely will need to look at T-Mobile, because they're the only GSM kind of carrier here in the U.S. that still supports 2G technologies. So I mentioned earlier that there are many different frequency bands around the world. Now, you don't need to memorize any of these numbers. I just wanted to show you that there are basically 4 GSM or 2G frequency bands, as well as 6 3G or UMTS frequency bands. So in order for a device to roam properly throughout the world, it would need to support all of these bands. And as I mentioned, most of them do, so it's not something that you typically need to worry about, but we always recommend, hey, make sure if you're going cross-country that your device supports all of these different types of frequency bands. So what's a good use of 2G applications? So 2G applications, as I mentioned, are really ones where you're not going to be transmitting a lot of data. So whether that's roadside signs, I mentioned you can do that with SMS, but you can also use that, just using standard cellular technology. Many of those signs still use serial ports, so you can essentially use, that kind of, you can essentially create a virtual serial port to those signs remotely, type in what you want the new message sign to say, and it will automatically be transferred across the cellular network to those signs. And it uses very small amounts of data. And because those signs are not changed very frequently, you are able to use one of the smaller types of data plans, which saves, of course, on cost. When we get into 3G, this is when we're sending or aggregating a little bit more data. So in this application example here, we've got some feeder terminal units that are essentially connected to a cellular modem. Now all the information that they have collected is being sent back across the network to a remote control center where it's then aggregated and monitored. Now because you're talking about sending multiple amounts of data from multiple devices, you are going to be looking at higher bandwidth requirements. So you will need the speeds of 3G in order to be able to send that data in a timely manner. Now the other thing to keep in mind is as you go up in generation, typically you go up in the amount of data or bandwidth that you need, which also means that you're going to have a higher bill every month because you're going to be sending more data across the cellular network. So CDMA is the other predominant standard that's seen. It is the predominant standard here in the U.S. It comprises only about 25% of all wireless users globally, but accounts for about 65% of all users here in the U.S. So in the U.S. here, Verizon, Sprint, and U.S. Cellular are the three big ones that use CDMA technology. Now, one of the pitfalls of CDMA is that in order to use a device that is CDMA globally, it needs to support quad-band CDMA, which basically allows communication onto GSM networks. And unfortunately, not a lot of devices do that. So if you are a Verizon customer or want to use Verizon or Sprint, you want to make sure that the devices that you're going to be using support that if you want them to roam globally. Now that being said, CDMA is very good in rural areas. The technology itself allows for better coverage per cell size. So what that means is that for each cell tower that Verizon, for example, puts up, they're able to get a little bit more distance and therefore more users onto each tower than GSM does. So that's why we see, carriers like Verizon be a little bit better in kind of the rural or out of the way areas, and why you tend to see a little bit better of a signal from AT&T, for example, in densely populated or citywide areas. So, what carrier you want to go with really kind of is dictated by where you're going to be locating your devices. So as I mentioned, CDMA is primarily a US-based standard, though there are CDMA networks that exist in other countries, namely Korea and China. They both have carriers that do support CDMA, and those are really the only two other kind of major countries that use CDMA globally. CDMA stands for Code Division Multiple Access, and within CDMA, every channel uses the full available spectrum, and individual conversations are encoded with a pseudo-random digital sequence. So a lot of mumbo-jumbo, but what it means is that basically you can't talk and browse the internet at the same time with CDMA, which is something that you can do with GSM. But what that means is the call quality tends to be a little bit better on CDMA. For those of you who are, using your cell phones, which of course we all do. CDMA as well also supports SMS, so if you want to use SMS in your applications, you can use it for both GSM and CDMA networks. So no matter what carrier you use, you can always use it. So 2G CDMA applications, very similar to what we see in 2G GSM applications because they use a very similar type of speed. I do want to mention that 2G has not been phased out by CDMA carriers in the U.S. yet. So if you have an opportunity, if you have an application that is going to only need 2G, such as signage, your best bet is probably to still use Verizon or Sprint as your carrier because they are not going to be phasing out 2G the way that AT&T will. So just a little note on that. If you all have very low bandwidth requirements that only need 2G, that's probably the better route for you to take. So in this application is very similar as the one I did before. As I mentioned, we've got a parking structure here that essentially has a digital sign telling customers how many spots are available. And that's great because you want to know if there's parking spots available when you pull into a garage. So you guys probably get the picture, but very low bandwidth is really what we're kind of saying here is best for 2G. So another example, 3G CDMA applications is actually remote light control and remote PLC control. So the PLC here is connected via serial to street lights and of course controls when they come on and when they come off. And that data of course is sent back to a base station which is then monitored. Now a lot of street lights tend to be in very remote or rural areas and so this is a better type of application for CDMA than GSM because again we have a little bit better coverage in those types of areas with CDMA networks. So LTE, let's talk about the technology that is all the rage nowadays. So why do you want to look at LTE for your applications? Well, LTE is really 4G for the future. So all telecom providers are really moving rapidly towards LTE. And what that's doing is it's essentially making GSM become a legacy technology. So I mentioned earlier AT&T is they call it sunsetting their GSM or their 2G technology. Though Verizon, Sprint, and T-Mobile have not announced those sunset plans yet, probably in the next couple of years, I would imagine they will start to do so. The reason for this is that it's driven by phone users. As you all know, everyone wants to do more on their phone, whether it's email, browsing the internet, streaming videos, watching movies, what have you. The trend on the consumer side is for more and more data, and so LTE is the type of technology that can handle that kind of data requirements. LTE also, it kind of helps in the reliability versus bandwidth. So GSM, CDMA are reliable, but of course lack the amount of bandwidth that you would see in a technology like Wi-Fi, for example, which has much higher bandwidth, but of course is limited in terms of its cell size. You can't just hop on a Wi-Fi network anywhere. LTE really looks to provide kind of a convergence of both of those, so it's kind of the best of both worlds. In addition to that, LTE has great backwards compatibility to the older standards. So most LTE chipsets that are being produced nowadays, they support both 2G and 3G fallback. So what that means is if you're in an area that has only 3G support, for example, your device can still connect to that tower because the chipset is backwards compatible. In addition to that, most chipsets support fallback to both GSM and CDMA networks. So what that means is rather than manufacturers having to create separate devices for CDMA and separate devices for GSM networks, they can just create one that will support both, which is really, really great. So this chart is a little bit of a busy, complicated chart, but the one takeaway that I would like you guys to see from that is that everything is kind of converging with LTE. So you have the GSM standards on the top and the CDMA standards kind of here in the middle in the orange, and you can see that all of these different evolutions are all kind of merging into LTE. So just kind of shows how everything is migrating into LTE and how you have that backwards compatibility in LTE to those various types of networks. Now LTE is getting to be more and more popular globally. You can see here in the red, these are all countries that currently have LTE service in deployment. So people are on it, people are using it. The dark blue is countries that have LTE networks that's currently being deployed or that is officially planned and announced. And the light blue is countries that have what's called LTE trial systems. So what that means is they're basically trying it out to see if they want to implement it, but likely they will be implemented once these trials are finished. So when you take all of those and you add them together, you can see that most of the populous countries in the world will or do already have LTE coverage. And this chart is as of May 21st of this year, so it is pretty current. So the advantages of LTE, just kind of in summary, low latency, which is key for a lot of applications that require specific timing. This was always an issue with some of the older cellular technologies. It has that higher network throughput, so it allows us to do video over cellular really kind of for the first time. It increases data transfer speed. It's very plug and play. It's very cost effective, as I mentioned before, since most manufacturers of equipment can use one single radio module for both CDMA and LTE or GSM networks. It means a lower cost overall because they have to buy less chipsets or less parts. It does include, of course, those improvements over 3G networks. And it's a very simplified upgrade path from 3G. So in the past, if one wanted to switch from GSM to CDMA, you were talking a whole new set of hardware and a whole new carrier. It's much easier now to just go to LTE regardless of which way you want to go. And again, as I mentioned, LTE modules tend to be backwards compatible to both GSM and CDMA networks. So when we ask about vertical markets for LTE, we tend to tell people, hey, these are markets that need a lot more bandwidth. So whether that's security with high-resolution video, whether it's mobile, you want to get your phones or your iPads, you want to do streaming video, whether it's remote monitoring of large amounts of data or an aggregation of a lot of smaller amounts of data, or digital signage, which is including multimedia and any kind of streaming video sometimes now even occurs on these signs. These are all appropriate types of applications for LTE because of the bandwidth that's available on those types of networks. So we have here an example of an LTE application for industrial use. In this application, basically 20 wellhead, they link directly to a remote central server and control center. And this allows for remote operations control, surveillance, and systems diagnostics for miles or, heck, even continents away. It's great because field technicians and site managers are notified of critical wellhead events either by SMS or email. You can set it up for both. And they can even access remote video feeds or sensor readings from the field by using any web-enabled smartphone, laptop, or tablet. So you can see how LTE kind of provides a convergence of all of the older technologies by allowing simple data acquisition or data transfer all the way up to real-time video monitoring. So as I mentioned, a great aggregation of the older technologies. So it's time for our last poll question here, and based on the information or what you've seen, which technology do you feel is right for your application? GSM, CDMA, LTE, or forget cellular? I want to go with a different type of technology instead. And we'll give you guys just a few seconds here to bring that to answer the question here. And wow, we've got it looks like an even greater landslide that's coming up for LTE here. Lots of you guys want LTE. Give you just a couple more seconds to answer. It looks like a few more people are still chiming in. And all right. So here is our landslide winner again, LTE. So lots of you guys want LTE, which is great because all the carriers are building up their LTE networks even as we speak. All right, so thanks guys for participating in our poll. We certainly appreciate it. So finally, the last topic that we're going to cover today is remote monitoring and connection. Now, as I mentioned earlier, most cellular providers are going to have private IPs given out. And the reason for that is that public IP addresses are very limited. As most of you are probably aware, carriers, most devices as well, still use IPv4. And the problem with that is that IPv4 addresses that are public are dwindling very rapidly. Each country essentially has an allocation of them. The US is almost out. So carriers tend to be very stingy about giving them out. So, what that means is that the private IP addresses, which are typically given out to phones or other cellular modems, are hidden from the public domain. Now, when you try to access a device from your laptop, for example, say you're trying to access a PLC that's behind a cell modem, well, both your PLC, the cell modem, and the laptop are all going to be on private IP addresses. And what that means is they can't see each other because they're on completely separate networks. So there has to be ways of essentially solving this problem or getting the data where it needs to be. The first way that you can solve this is by doing a software solution, and most vendors that make cellular modems will have some sort of a software solution, but it basically allows private IP hosts and cell modems to communicate with each other. And the way that they do this is that the software is typically installed on a server that has a public IP address, whether that's a web server, an FTP server, and it essentially allows both private IP addresses to communicate to it. It opens up bidirectional ports on either direction, and then it allows the data to essentially flow through it. So it acts almost like a tunnel or a redirecting type of a device. A lot of these software services tend to be free. Again, they just require an installation onto a public IP address. Another way to get around this is doing a carrier VPN or a carrier tunnel. So most MVNOs, which as I mentioned are mobile virtual network operators, will provide a tunnel connection to their private IP SIM cards. And an MVNO essentially is a reseller of airtime, but they're one that specialize in true data or industrial type applications. So what that means is they buy large chunks of airtime from AT&T or Verizon or Sprint, and they basically resell that to you. They typically have dedicated network operations centers that are up 24/7 because they understand kind of the critical nature of industrial applications. If your cell phone doesn't work for a day, it's probably not as big of a deal, but if you have a device that's down, it's costing a company money, that's a much bigger deal. Now, carrier VPNs, they also allow a dedicated secure access while maintaining an ease of connection, so they're always connected. It's a very low-cost solution. Most MVNOs will charge around $5 or $10 a month to have that tunnel be active. The only downfall is it does require a PC to connect, so it's not good for device-to-device type communications. The final way of doing it is a public IP address, which is the easiest way to access your devices. It's public IP address, so you would access it just like you would access google.com, for example. You just type in the IP address and you're connected. The nice thing about public IP addresses is they allow for port forwarding, which means that whatever device is connected to a cellular modem, whether it's a PLC, I/O device, SCADA system, you name it, it'll automatically forward your computer onto that device as if you were physically connected to it, and that's not possible when you're talking about a private IP address. However, there are some downsides to a public IP address. It is unsecure, so those who are worried about security tend to shy away from that because anybody can, of course, access that device. And it does have a high cost associated. Carriers will charge anywhere from $100 to around $500 a month for a public IP address, so it is significantly more expensive than a private IP address. So that brings us to our conclusion page. Just kind of a quick summary for you guys. Cellular modems, of course, are great because they allow network access for almost any kind of device, almost anywhere in the world where there is not an existing network, as long as there's cellular coverage. GSM is better suited for global use or for devices that can be shipped globally. CDMA is better suited for US or urban or rural use. LTE, of course, combines the best of both, and there are multiple options for accessing a device with a private IP address. And with that, I believe that brings us to the end of our presentation. I'm going to turn it back to Marty here. He's going to do some Q&A.
Great. Thanks so much, Ariana. Tons of information there. Hope you guys able to glean some of that information that Ariana presented. With that, we're going to get into the Q&A section of the presentation. The first question, Ariana, comes from Samuel. Samuel asks, if I have a CDMA device, can I use it on GSM networks as well? So I'll hand that back to you.
Thanks, Marty, and thanks, Samuel. That's an awesome question. The answer to that for the majority of the time is going to be no. So the one exception is if you have a CDMA device that supports GSM bands as well, you can switch that over to a GSM network. Those devices tend to be kind of far and few in between, even in terms of phones, unfortunately. So if you have any older phone that's on Verizon or Sprint, for example, you can't take that over to AT&T, or you can't take that over to Europe or Asia and use it. And that tends to be kind of the trend for CDMA. But as I said, there are exceptions, so it will depend ultimately on what type of equipment or what type of modem you're using.
Great, thanks, Ariana. The next question we have is from Dan. Dan actually has a series of questions, but we'll get to them individually. The first one, he asks, for mobile applications, which is better, cellular, mobile WiMAX? I guess he's asking in terms of throughput and reliability, so maybe shed some light on that.
Sure. Thanks, Dan, for the questions. That's a great question. So it really it depends. So WiMAX is definitely going to be better in terms of throughput. Reliability is going to be kind of a toss-up between the two of them, though I will say cellular, in particular LTE, is going to be probably the best option of the three. The reason for that is you have the throughput for WiMAX, you have the coverage of cellular networks, and you also have a much better reliability. So that's probably going to be the winner in terms of that. WiMAX, as I mentioned, has great throughput. It is very reliable, but it's not very prevalent in the market, so you're going to have a harder time kind of finding a WiMAX network to connect to. Now, if you already have a WiMAX network in place, it can be definitely a very viable option for you, or if you're looking to implement one individually.
Great, thanks, Ari. The next question we have is from Philip. Philip asks, what equipment is required at the head-end office with the application example showing the G3110? So if you want to refer back to that slide, what Philip's talking about, or maybe just off of your own knowledge base, the type of equipment that typically would be used in that type of application.
All right, well, thanks for the question, Philip. When you're talking the head-end office, and I'm not sure which application you're talking about, but typically the equipment that's required on the head-end is simply a PC. So whether you're talking about Ethernet or serial, you typically will need a computer that you would normally use to connect to that end device. So if you're talking about the sign example, basically where you would have a computer that you would program to connect to the device, or excuse me, to the sign directly, you would now just connect it virtually to the internet, and basically you would just need the cell modem on the sign side. So there's not really a whole lot of extra equipment that typically is required on the control end. You would normally just use whatever equipment you would normally use to communicate with those end devices.
Okay, great. Thanks, Ariana. Next question, again, this one's from Dan. He asks, theoretical max user data rates, how are these figures computed? How do they relate to the Shannon limit? So if you're familiar with that, shed some light.
Thanks, Dan. I have to say I'm not familiar with the Shannon limit, but the theoretical max user data rates are they are computed by the actual hardware itself. So the hardware is tested to theoretical basically limits, and the hardware is physically capable of transmitting at the limits that are basically stated. Now, what you're actually going to get in reality is going to be totally dependent on the carrier themselves. So while even some of the carrier hardware may support some of those higher bandwidth limits, they may either limit it manually, whether they say, okay, we're only going to give each user 2 megs down, for example, or whether that is not rate limited but is limited based on how many users connect to a tower. So for example, if you have a tower that has, let's say, a 10 meg pipe to keep it simple, and you have 10 users that connect to it, that basically allocates 1 meg per user. So that's kind of a soft limit on what kind of data rates you're going to get. But those theoretical ones are based on the actual hardware and what the hardware can support.
Awesome. Thank you, Ariana. The next question, and thank you all for your questions. We have a ton of questions coming in, so we'll try to get to them all. The next question comes from Karen. Karen wants to know, if I bring a device to the U.S. from another country, will it work in the US? So maybe shed some light there.
Sure. Thanks, Karen. That's a great question. For the most part, yes. As I mentioned, most countries globally will use GSM standards, and those GSM frequencies are basically used throughout the world. So if you're coming from Europe, for example, or you're coming from an Asian country, and they're using GSM, and you bring it here, then you can use it on any GSM network here in the U.S., whether that's AT&T or T-Mobile. There are a few exceptions. There are some devices that are made solely for like European carriers, for example, which won't work here, or if the device is locked to a specific carrier. But those exemptions tend to be, the exception to the rule rather than the rule itself. So for the most part, yes, you will be able to use global devices here in the U.S., presuming that you're okay with using AT&T or T-Mobile.
Okay, thank you, Ariana. This next question is from Martin, actually my namesake. He asks, what is the product series from Moxa that allows for cellular connection? So I think that should be a pretty quick one.
Thanks, Martin. So Moxa offers a series of cell modems. They're called the on-cell devices, and we have ones that include both serial and Ethernet to cellular. So whether you're looking, to just kind of update an old serial connection that you have to PLC, or if you're looking to bring an entire SCADA system online, we do have products that meet those requirements. And again, that is the on-cell series.
Awesome. Thank you, Ariana. This next question is from Girgis, and I apologize if I said that incorrectly, but Girgis asks, in regards to positive train control, PTC, how do you see that as it relates to LTE and that technology?
So LTE is the first kind of cellular technology that can be used a little bit towards PTC. I will say that we haven't seen a huge increase in a trend of using cellular for PTC just because of the slightly more critical nature of it, but LTE would definitely be the technology of choice. There is a rail standard called GSM-R that was meant for the rail industry specifically, but it was very low bandwidth. So I would imagine that we're going to see something similar occur with LTE. It's just that, to my knowledge, nothing like that has quite been implemented yet.
Great, thanks, Ariana. This next question is from Roberto. Roberto asks, since in many applications the cellular gateways are located far from service locations or a watchdog timer that can reset and reboot the gateway, in case of a failure or predetermined times, will Moxa gateways have the capability of that he's talking about in the future? So.
Thanks, Roberto. Likely that is something that we're going to be developing in the future here. We do have a technology that's called GuaranLink that's currently built into our products that essentially is kind of a heartbeat, if you will, and it monitors the connection to make sure that it doesn't break down or go away or disconnect, and will attempt to reconnect in the case of disconnection. However, that's really great feedback for us that is something that we definitely will look to develop and put into the products in the future.
Awesome. Thank you, Ariana. The next question comes from John. John is asking, in a question where there's no LTE, would GSM Cellular be the only and best choice to use if you want to run both a GSM tracking device and a video real-time tracking device in public buses?
All right, thanks, John. Yeah, if there's no LTE where you're currently looking to do it, I would say at least make sure that there's a 3G network, whether that's likely going to be HSDPA or HSPA. I assume that you're talking outside of the U.S. Most countries will have HSPA networks. Those are, I want to say, acceptable for video. You will likely need to make sure that the video is not very high quality or at a very high frame rate, just because the technology is not capable of handling it. The other potential issue that you may see is that the latency tends to be worse on a 3G versus an LTE network. So you may see chops or breakups in that video. It won't be quite as smooth as it would be on an LTE network. But yes, it certainly is possible. It's just not something that people tend to implement just because the quality is not as good. But yeah, definitely possible.
Okay, great. And the next question, another one from Dan. or it might be two questions. He humorously asked if there's a glossary for all the acronyms, so maybe that's something we can provide in the Q&A as well. But this other question just came in. He wants to know what we might know about Amtrak's passenger Wi-Fi, or maybe a solution that you might think would work there, Ariana.
I know a little bit. First of all, acronyms. Yes, we can certainly include an acronym glossary in the Q&A. So thanks, Dan. That's a wonderful idea. I know we tend to, we kind of tend to take it for granted here that a lot of people know what the acronyms mean, but we realize every time that most people don't, especially those who are new to cellular technology. So yes, we will absolutely include that for you. In terms of Amtrak's passenger Wi-Fi, what I know about it is that a lot of them are using a combination of cellular and Wi-Fi. So what that means is there is a device that sits on there that tends to support both. So when it's in a station, when the train's in a station or someplace where there is Wi-Fi, it will basically use that network to give access to passengers. And then when the train is outside of a station and is on the track, for example, it will basically use its cellular connection to provide that access, that Wi-Fi access to users. And that's probably going to be one of the best options that there are. That would save cost because you use a Wi-Fi connection when it's available and a cellular connection when it's not. And that's a very similar issue that a lot of bus manufacturers are facing as well, because a lot of them are putting Wi-Fi into bus stops or into depots. It basically allows them to kind of have the best of both worlds.
Great, thank you so much, Ariana. And it does look like we're at the end of our session. We've had a few more questions than we have time for. Please know that we'll get to those questions and we'll get them answered and respond to them after the webinar. So again, thank you, Ariana. Thank you to everyone for your interest and participation. Also, you'll be receiving a follow-up email with both the recording and presentation slide deck. Lastly, please take a minute before logging off to fill out our survey, as we really value your input and feedback. Thanks again for tuning in, and have a great rest of the week.